Welcome to Kobo booth at OFC 2019. This is a big transitional year for Kobo. Last year we demonstrated that we had a spec available. This year we're actually demonstrating a full Kobo ecosystem. We have a switch, we have adapters, we have optics, we have optical connectivity, we have compliance test boards. We have a full suite of stuff going on here this year at OFC. So let me walk you through it. So the first thing we're going to show here is a Molex platform that's actually showing the different ways you can actually build these systems with optical connectivity that you can do with modules inside these systems surrounding switch ASICs or being used for optical backplanes or optical faceplate. We've also taken some of that technology and actually built a live demonstration this year. This is a Kobo proof of concept switch built by Microsoft Delta Networks in partnership with AOI and 3M, Senko, and Sumitomo, showing not only how you build a network switch with Kobo modules, but also how you can do the change of the connectivity on the faceplate using an air gap style connector, this one built by Sumitomo, using a small connector that's built by Senko, and then using a lensed, let's put that boy back in there. These things are really small. And then also using a lens connector built by 3M. You can also use the standard MPO style connectors or standard LC connectors. The other thing that's very unique to this platform, it is the only switch on the show that is showing Kobo by 8, Kobo by 16, OSFP module ports underneath, and QSFP-DD module ports. So this switch is actually capable of evaluating and testing all these for system deployment. Next door to this, we have a demonstration by AOI of their 4x100 gig PSM4 optical module, transmitting and receiving data, and they are passing it through a multi-lean tester. We're showing this operating, driving 400 gigs of optical bandwidth in a by 16 module. What they've done is they've taken 4 individual 100 gig PSM4s, they've encapsulated in a by 16 module, and they are driving it with 25 gig. And this is what it looks like if you deploy it in a system. It's one of these by 16 modules inside the system. Over here, we have a board that was built by Sienna and Senko to show the various forms of using optical modules. These are by 16 Class C modules. This is to evaluate thermal environment and different connector capabilities. So this board is used to actually do thermal and PCB testing and evaluation as to what they can handle and the amount of airflow required and just how well this system will perform in high temperature environments. And shifting to the back, we have a demonstration back here of a high-speed connector done by TE showing multimode fiber transmission. Now this connector is showing the Kobo, inside the Kobo module built by Petra. These are the small little multimode fiber VCSEL transceivers. And you can see it, what they built is an adapter card. This is an 800 gig bandwidth adapter card with an FPGA and 2 modules passing 400 gigs of bandwidth each. And over here we have Credo showing with TE connectivity, showing the ability of the Kobo high-speed connector to handle 100 gig PAM4 electrical signaling. The reason why this is important is that in the next generation of technology, the standards bodies are already working on 100 gig PAM4 electrical signaling, and that will be the next generation of interconnect technology. That means Kobo is prepared to be able to do 1.6 terabits in an optical module with the way we built it today. To tie it all up and to be able to evaluate and test that, Rosenberger is demonstrating their host compliance board and their module compliance board to be able to do electrical performance and evaluation on these systems. So this gives anybody building it an ability to actually, if you build a system, a motherboard for it, you can buy these to test the motherboard electrical signaling. If you're building optical modules, you can buy one of these to test the module electrical signaling. And we also have Sumitomo showing that connector, that air gap connector that was in the switch, showing it in a very high density gang faceplate. So in some places where you're doing a high number of connections, you don't necessarily want to have to do each single connector. And this allows you to plug in multiple connections all at once with a high number of fibers and a high reliability of connectivity. And then finally, we have US Connect is showing how you can do optical systems inside these motherboards with running traces, using various expanded beam connectors, using their new prism style connector to mate onto some of the devices. So they're showing optical connectivity built into a system here that would do both. These are other types, proprietary types of embedded modules, but they're also showing how you could do it with Kobo style modules. And that's a wrap up of the Kobo booth. Come and check it out in 1817.